This lesson's all about symmetry, and we're going to focus first on line symmetry and then follow up with rotational symmetry. We've talked about both of these concepts before, but now I want to go a little more in depth. If you have a figure that can be mapped onto itself across from a line, then the figure has line symmetry. And the line would just be denoted as the line of symmetry. So this butterfly, for example, you can take and cut it right in half, and it's symmetric on each side. Each point can be mapped onto a corresponding point on the other side, so it is symmetric. So when you take figures, you can draw lines of symmetry by splitting it up in half as many different ways as possible. So for example, here we have a pentagon, five-sided figure, and it can be split up in 5 different ways. Notice though how I have 1, 2, 3, 4, 5 lines of symmetry, and then these over here we're not going to count again because we've already counted them. One extends from this point all the way through. Similarly, for this octagon we have 8 lines of symmetry. So you'll see a pattern that in regular polygons you have as many lines of symmetry as you have sides or vertices. To find lines of symmetry, we can start cutting figures into pieces. So there I drew my first line of symmetry. It is symmetric. They're mirror images of one another. And I continue in the same fashion to draw all of the lines of symmetry. And what we find is that this figure has 5 lines of symmetry. Looking at the rectangle, there's only 2 lines of symmetry in this one. We can draw the horizontal and vertical lines of symmetry, so there's 2. And then this last figure. Now, if this was a regular pentagon like in the previous page, we would say that there was 5 lines of symmetry. But in this case, since it's squished down a bit, there's only this 1 line of symmetry. So this one has 1. When looking at rotational symmetry, we say that a figure has rotational symmetry if it can be mapped back onto itself by some rotation of 180 degrees or less. And it is important that it's 180 degrees or less. So it could be from 0 to 180. And here I have a windmill. When you start rotating this windmill, so this first one we start at its original point, and we start rotating it counterclockwise. We go 45 degrees, but it's not enough to get back to the original position. Now if we go a full 90 degrees, it would fit back right on top of itself. So these pictures, the first one here at 0 degrees and 90 degrees, are both in the same orientation. Similarly, if you rotate the original picture and the image 180 degrees, they end up in the same position. So here we do have rotational symmetry of 90 degrees. To figure out if a figure has rotational symmetry, we're first going to draw the lines of symmetry. So we draw the first one here and the second one there. And then ask yourself, think of this as a puzzle piece. That's what I like to think, where if you pick it up and rotate it around, will it fit back on itself with only a rotation of 180 degrees? And what we notice is that this point here, if we rotate it 180 degrees, ends up right here. And yes, this does have rotational symmetry of 180 degrees. Now, this second example, we draw the line of symmetry. And if we try to pick this one up and rotate it around, we're not going to get back to the original position until we go all the way 1 full circle, because the object itself is only symmetric across 1 line. So this one does not have rotational symmetry. In your notes, finish up the examples that I ask you to complete, and we'll discuss them when we get to class.